record.
Yeah.
All right. Hi, everybody. Welcome to Summer Bridge. My name is Professor David Parent, and I'm an EE faculty at San Jose State. I'm really excited to be here and to lead you through a project of stochastic resonance. Now, I didn't want to spend too much time teaching or with a huge introduction of myself, just because I feel you've probably been doing a lot of listening for the past day and a half. But what I would just like to do right now is have the TAs just say hi and go in the order of Alex, Elisa, Rupinder, and Shifa. So just say a brief hello, what your major is, and what year you're in. Alex.
All right, so I'm Alexander. Yep. I am a computer engineering major. I'm going into my second year, so I feel real youthful here with everybody, especially during the transfer project. And I'm excited to hopefully get you guys up to speed with what we do around here.
Elisa?
My name is Elisa. I'm also one of the TAs. I'm a fifth year electrical engineering student, and I'm glad to see you guys again.
Rupinder?
Hello everyone, I'm Rupinder. I'm an incoming senior majoring in electrical engineering, and I'm very excited to be with you today.
Hi everybody, I'm Shifa from master's program. I'm from electrical and I'm very excited to work with you. I hope you enjoy the program.
Okay, so I just so you know, I normally turn off my video so that my face isn't distracting when I'm teaching. Okay, and maybe just a few ground rules is that my email, it's probably the quickest way to get a hold of me. All right. And usually if you just respond to one of the Canvas messages that I've sent out, you can do that as well. Now, when we start breaking off into our breakout rooms, I would like it if you had a question, go to the TA first, and then if it can't be resolved, then you can bump it up to me. But I have a feeling some of you will work outside of the official time. And if you're outside the official time, just send me an email. And if you find the answer 5 minutes later, just send me an email. It's not an annoyance or a bother. I enjoy working with you all. Oh, and then during class, I'm not quite sure what it is, but when somebody has a question or sends a chat, it doesn't really notify me. So you might just have to unmute yourself and kind of, professor, and get my attention. And I don't have a problem with that. I know a lot of things about Zoom, but I haven't been able to figure that bit out. So I really encourage you to read the Canvas section module, where pretty much everything, the learning objectives, how things will flow, mostly what we'll be doing each day, the lab manual, it's all there. And there is an assignment there, and it's just a review assignment that I can go and check and see what I might need to concentrate on. Because we can't really guarantee that everybody has the same level of prerequisite. And the truth is, you could know things very well, let's say in May when you took a final exam, but unless you've been working with it for, every day since then, you tend to forget. So I don't really worry the fact that it's got points or anything like that. It's a formative assessment, which is really just to tell you how you're doing, right? And I know we have a variety of majors, and not every major needs EE 98, but the thing is this project and some of the things that go along with it are useful to every major. So I just want to start with the idea, just to get a brief overview, is that we're going to do something called stochastic resonance. And you have a system where you add noise and a signal, and the noise actually makes the signal come through more clearly. And it's really counterintuitive, where normally noise is something that destroys a signal. This actually improves it. And it's not really a resonance that you might think from like physics. Like, let's say you're taking a bath and you start swishing the water back and forth, and if you can get that wave to propagate back and forth at the right time, right, you can get a huge wave and kind of splash everything out of the tub, right? Or the resonance of a musical instrument, or the resonance of a inductor capacitor circuit. So, but the reason why it's considered resonance is that at certain frequencies, the effect will be more noticeable, or noticeable at all. All right. The device we're going to be using, all right, we have an op amp, which we're going to go over, right? Oops. And we're going to add our noise here. And then we're going to have two resistors connected in a voltage division way, which we will review, right? And this is a Schmitt trigger, and it's normally used to get rid of noise, which is even more amazing. And then here, we'll add like a sine wave. All right. Not every frequency of sine wave will work for the input noise. All right. So oh, okay. So so the thing is in this these 2 weeks, you will learn or review the basic theory of this, right? And then you'll use an industry standard tool called LT-Spice to simulate it, right? And then you will actually build it and test it with the kits you should have received, which are actually pretty amazing. And while I do have what you might call industry standard oscilloscopes, function generators, and power supplies at my house, I've been using this, and I'm kind of liking it better than my standard test equipment. It's pretty powerful. And these things, if we want, we can always have a side conversation and talk about how all of this would relate to your own individual major, all right? Now, sure, I'm an EE, A lot of the TEs or TAs are EEs, but we're trying to make this project exciting and doable by everybody. Now, what we will be doing is you're going to be following essentially a lab manual. All right, which can be done pretty much independently. So if your internet goes, that's okay. But when you have a question, yeah, log back in, or what you can do is that when we go into breakout rooms, then we're going to assign you randomly, but then that'll be your TA for the rest of the session. All right. And then ultimately your teams will come out of those breakout sessions. All right. But you can do all of this pretty much with a PC. Everything's free or open source. And if you have a Macintosh, you can even remotely log in and use a virtual server. If you're having trouble with that, it could be that you have to use another virtual server a virtual private network to log into campus, which might not be in the lab manual. If that's the case, I'll figure that out and help you. All right. But I know that when you're learning something new, especially with a tool or a software, there can be that moment where you're just banging your head against the wall in frustration. Really, at that point, or before that point, you should contact your TA. We're here to help, and we're here to be on the same team. And really, while we can have our like little mini learning objectives, I have a longer term or a higher thing that I'm trying to find out. And as I would really like to have undergraduates involved in authentic research tasks. And so many times as professors, we kind of think, well, in order to do anything real, you need a PhD. And it's not true, but it can take some reorganization of our thought of how to best include undergraduates in our research activities. And I've been guilty of this myself, but I've been working with the College of Science, and they're pretty good at it. They're able to have students actually publish their work, and I really would like to, and I think we can do the same. And so I'm kind of running this as if I am onboarding you into my research program. Now, so yeah, if you wanted to continue during the semester, that's okay with me, right? We can have a research meetings and you can keep after it. And part of learning how to work with undergraduates is being able to handle it when you all have exams or homework or work, and to be able to handle the bursty nature of how students work. And I'm still working on that, but I would say is there's no GPA minimum, there's no prereq that you have to have, because it seems in preliminary work that I've done, it's really just how hard you work. That, because you can learn anything if you put your mind to it and you're interested in it and it excites you. All right, but that's for later. Now, a lot of the nitty gritty, it's in the Canvas shell and things like that. However, and I've tried to pre-answer a lot of questions, but do you have any, does anybody have any questions? And you can, now I have the chat thing open. So if you want to chat it, and I think you can even chat me directly if you feel uncomfortable chatting everyone. Okay. I'm just scrolling through who we have.
Professor,
Yeah.
just to
Oh,
echo some of the things people I think are already saying. It's really exciting to hear you say that, that we might be able to continue doing this sort of stuff during
is
the
that
semester if you like it.
you, Sophia?
No,
No.
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 I'm Sophia.
Okay, no, I'm reading. I'm sorry. So it's interesting you say about the chemistry, because I got a textbook lent to me by one of my chemistry colleagues about how they do it.
He actually, it was his major was chemistry, but it was a chemical engineering lab. And it was really like just fundamental for building lab skills and
Yeah,
learning
yeah.
how to write and publish and just having something published when he got his bachelor's degree. So it's an
Where did he
awesome
go?
opportunity. He went to UC Riverside.
Okay. Yeah, our chemical engineering department has, I think, a similar structure. But this is the mind-blowing part about this. Sorry, I'm going to get a little bit excited, so just everybody relax. But this stochastic resonance comes from randomness, which we call noise, but I think I like random signal better than noise, because if this noise is useful and noise isn't useful, well, then it's not a good name. But it comes from random motions, right? And these random motions from one state to another, which is fundamental to how chemical reactions work, which something Einstein was one of the first things he worked on. But this random motion, another term for it is Brownian motion, Brown was a botanist in the late 1800s who was looking at pollen under a microscope suspended in water, and then noticed that these pollen molecules are bouncing around for apparently no reason at all. And so something that a botanist did in the 1800s led to, how are the chemical reactions moving, then ultimately leads to a project that we're doing today. Sorry. All right. Now I'm relaxed now. Now, kinetic theory. Listen, I'm still in EE. I took chemistry 1A, and I have wide swaths of ignorance. So
Sorry.
okay. It's okay. But yeah, I mean, if you hear any typing, that's me like Googling whatever you just said.
I've been reading a PChem book over vacation, and I'm really excited about it now.
All right. All right. So I'm gonna. All right. PChem stochastic. So, so what I thought though is, wow, so PChem stochastic resonance came up in Google Scholar. There's a paper cited by 163 people. And yep. So what I
Tons of
thought,
reactions.
yeah. So, and now I'm getting really excited. And so I think what we can do is, I think I want to carve out time for these kinds of conversations later, but get you working on the tutorials. And then and I'll just leave it at that. I'll let you, but I think I'll figure that out. I'll figure out a way we can have these conversations. And then two, what in that conversation, I can maybe make an introduction to whoever faculty you'd be interested in. And it doesn't have to be stochastic resonance. You could, this is what I'm into, and you're a biomedical major. And I know they're all my friends, and so I know who's working on what. And I can just give you that kind of introduction and say, by the way, they have this skill set that they could help you with things right away. Now, again, everybody's a little bit different, but that's what I think. But are there any questions, just, kind of like a mundane administrative thing before we all put you randomly to these breakout sessions? All righty. Again, you can always just email me. So Shifa, if you could, do you know how to do this, right?
Yeah.
Okay.
So total participants are 17.
70.
17.
Oh, okay. So yeah, so then subtract me, because each four of you and so and we're going to have to add people, because I know of at least two people who couldn't, they're in a study hall or something right now, and they'll be joining us later. But yeah, so just randomly assign, actually, yeah, just divide it into 4, and I'm going to stop talking. I'm going to read about stochastic resonance in chemistry.
So just bear with me, I'll assign.
Oh, and everybody, before Shifa breaks you out, when you go into your breakout room, go and introduce yourselves to each other. Okay.
It's sorry, it's taking a little bit of time because I have to divide everyone.
Oh, but there should be a divide randomly option.
Yeah, but like I have to assign TAs to that, right?
Oh, but
Yeah.
I think as TAs, you can just join whoever you feel like. And so while you're waiting, unless you have already done it, I would, yeah, just start working on the tutorial. It should be, I would get it directly from Canvas, and the revision date should be for August. And
Yeah, you get the request.
okay, and I'm gonna join, but then I'm gonna leave.
Yeah.
Okay. All right. Have fun, everybody.